we go. We have, well, I can even do a circle here. Let's see here.
That's cool.
I think I need to make it, have it be white though, with red outside, like this. Okay, there's a circle, and it has a shadow, which is a little weird.
Oh, you can turn off your shadow.
I know that. Let's see here. Let's do it. Shadow off. Okay, let's do a square here. Okay, this is looking pretty good.
The circle has been carved into the sheet.
Whoops. I'm going to undo that last one. Okay, so what we have here is we have a circle.
What about the little ones?
I'll get there. Those are harder to do. We have a circle, and the circle has radius, what, 5?
Mm-hmm.
The circle has radius 5.
Okay.
And we're also told that there are these little squares on the outside here. And all we know is that they're squares. In other words, so they're whatever exact size they need to be. They're not very squarish because I'm drawing them freehand. Okay, so we've got these squares, and then we want the total area of the squares. Okay, so first things first, let's figure out the area of the big square. If I look at the diameter, of course, is 10. And that's a diagonal of the big square. Mm-hmm. Right?
Yeah.
Which means the side length is how long?
10 divided by root 2.
Right. Okay. So this side length is 10 divided by root 2. Okay. So the area is that number squared. Mm-hmm. Right? And that works out to be 100 over 2, which is 50. Okay. So the big square has area 50.
Okay, yeah.
Okay. Now, to the hard part. Let's use a different color. How about blue?
Yay.
We're going to call the side length of the small square, we're going to call that x. Okay? And what I'm going to do is I'm going to draw radii where I possibly can. Okay? That's kind of like whenever you have a circle, you want to see where can you draw the radius. Okay? So if I construct myself a right triangle, like so, okay? What are the side lengths of this right triangle that I have just constructed?
The side lengths of your right triangle, that's the radius of the circle, right?
Yeah, so the hypotenuse is easy. Hypotenuse is easy, right? That one's 5. Okay? So I can just leave the 5 right there. This side right here is exactly half of the square side length.
Mm-hmm.
Right?
Yes.
So that side would be x over 2. This is a little bit different from what I said yesterday. Because remember, yesterday I used a bigger triangle, and then we looked at the solutions, and they used a smaller one. So just I'm going to pause for a second. Just say, yesterday when we looked at this problem, I actually used this triangle.
Make it thicker.
Okay. I actually used this triangle. Okay. Do you want to use the same triangle as yesterday, or because the triangle we're using today is just this little bit, this little part of it. So the triangle we're using today in bright blue, the triangle we used yesterday in turquoise blue. Pick which one you want to use today.
We've
already started on the bright blue one.
Then let's keep going with the bright blue one.
All right. Now, switching back colors. So I'm going to go over here and I'm going to draw another copy of the bright blue triangle for clarity's sake. This side length is 5.
Okay.
This side length is x over 2. Right?
Mm-hmm.
Okay, so this side length, the bottom, consists of 2 pieces. One of the pieces is exactly x, right?
Mm-hmm.
And the other piece is exactly half of the square's side length.
Okay.
The brown piece right here, that's half of the side length of the square, and then this right here is x. Okay, so what is half of the side length of the square? Do you remember? We got it written here.
The side length of the square.
Remember the side length down here?
It's 5.
5
No,
over root 2.
5 over root 2.
Right, so this is the whole side length, which means half of the side length is 5 over root 2. So that means all told, this bottom length is 5 over root 2 plus x. Agreed?
Uh-huh.
Okay. Now, we have gotten ourselves in a Pythagorean situation.
Okay.
Right? So we need to do x over 2 squared plus 5 over root 2 plus x squared equals 5 squared, which is 25.
What is that area?
Uh-oh. Be careful. Be
I
careful.
won't touch it.
What?
5 over 2 plus x?
Yeah. Do you understand why that's that side length right here?
I don't get the x part exactly.
So the x part...
Oh, is it this much?
Yeah, it's the square there. And then 5 over root 2 is exactly half of the square that we started with.
Mm-hmm.
Okay.
Mine isn't the best drawing.
All right. So now I'm just going to create space down here. What was it? X over 2 squared plus 5 over root 2 plus x squared equals 25. Okay. Do you know how to FOIL this out?
I think I can.
Okay. So
Stop the video.
I'm going to hit pause. Okay, so, and there we go. Suddenly all the algebra appears. All right, here is a little trick that's going to make life a little bit easier. If I multiply both sides by 4, I don't have to deal with denominators.
What about root 2?
Well, there's no way around that part.
Okay.
But, in other words, I'll have x squared plus 100 over 2 plus 40x over root 2 plus 4x squared equals 100. Okay? Anytime you have a quadratic equation, you want to get everything on one side.
Mm-hmm.
So I'm going to move the 100 over. I'm going to collect the x squared term. So I've got 5x squared, right? Plus 40x over root 2, plus, what is this? That's 50, but then not plus, minus 50 equals 0, right? Okay, now to make life easier, I'm going to divide everything by 5.
X squared plus what? X squared plus 50 plus 40x over root 2
Equals 100.
4x is equal to 100.
Where'd you get that 4x squared? Okay, yeah.
The derivative.
And then you're collecting these to make 5x squared.
Where? Which ones?
4x squared and x
yeah,
squared.
5x squared plus 50 plus
40x
40x
over root 2. Yeah.
Minus 50 is equal to 0.
Okay. And then I collected terms.
Then you divided everything by 5
Yes.
plus.
Just to make it easy. All right, now I'm gonna hit pause and write down the quadratic formula. Okay, so I started writing out all this new stuff. So I wrote out the quadratic formula. It appears all of a sudden, and then I started collecting the pieces of the quadratic formula, and then you stopped me and you said, "What happened to x?" So in the quadratic equation setup, I've got ax squared bx plus c. So in other words, this bit that I'm circling right here is b,
Okay.
right? So a, b, and c are numbers. So that means this whole recipe here is all numbers.
Okay.
Okay, so now let me back out, and like I said, I'm collecting all of this stuff one at a time. 8 over root 2 squared is 64 over 2. And then we got plus, what's that, 40? Right? You got to be careful about the minus here. The c is negative 10. Okay, and then all of that is going to be...
We have negative b, but we don't have any of the other ones.
Right, and then 2a
Did you just
is
stick in the
2.
quadratic formula already?
No, I haven't. I'm collected negative b,
A is 1.
negative b, b squared minus 4ac is what, 72, right? 32 plus 40.
This is so weird.
And then down here I've got 2, okay? So I've got what pieces go into this formula. I've got negative 8 over root 2 plus minus square root of 72 over 2.
Okay.
Got it? Okay, so the whole point of doing this, and this is to just organize my calculation. The quadratic formula has 3 pieces.
But can't I just stick it in without organizing it?
You could, but I promise eventually you'll make a mistake if you do it that way. Do it. I'm also doing it because I have this tiny little screen where I'm working. So let's do it that way because you think that's the way you would do it.
Yeah.
So let's start back over with the quadratic equation. You had x squared plus 8 over root 2x minus 10 equals 0. Okay, so negative b plus minus square root of b squared minus 4ac all over 2a becomes, you ready? Negative 8 over root 2 plus minus square root of 8 over root 2 squared minus 4 times 1 times minus 10. All of that over 2. Happy?
I think so.
Okay. Now, minus 8 over root 2 plus minus square root of 64 over 2 plus 40. All of that over 2.
Okay.
Happy so far?
So far.
Okay. I'm going to hit pause and let you catch up on your paper. Now what? We got to simplify the radical. 72.
True.
So
There's an
you do
8
it.
in there, and there's a 9.
There's an 8 and a 9. Or, okay, so the 9 becomes 3 root 8, right? Minus 8 over root 2 plus minus 3 root 8. But then 3 root 8 becomes what?
It should be 6 root 2.
Okay, so we'll write 6 root 2.
Over 2.
All of that over 2, right? So in other words, I have minus 4 over root 2 plus minus 3 root 2. Now we actually got to get rid of this root 2 in the denominator,
Okay.
right? Because I got to get...
Wait, what did you just do?
I just canceled the 2 with the 6 and the negative 8. Okay, you know how to get rid of the root 2 in the denominator, right? What do you do?
I'm not sure what to call it, but you multiply root 2. Negative 4 over root 2 times root 2, and then the
Exactly.
4 times root 2.
Negative 4 root 2 over 2 plus 3 root 2 plus minus, sorry. That's negative 2 root 2 plus minus 3 root 2.
3 root.
I say let's take the plus, otherwise we have negative squares, right?
Well, these I can just cancel out.
X equals the square root of 2.
So let's take the positive. So 2 root 2, negative 3 root 2, plus, just plus, it's 3 root 2. So you have so you have root 2.
Root 2, that's what X was. Okay, let's go all the way back to the beginning of the problem.
Or
All the way up here. Remember at the very beginning, we figured out the area of the big square, and then we said we've got 4 of these little squares that have side length x. And now we agree that x is root 2, which means that x squared is 2. And we've got, what, 4 of those?
Yeah, 4 of those.
58.
We had said that the...
Hopefully that's the answer.
I think so.
Okay.
That has.
Anyway, I feel like if they didn't get that answer, they made a mistake. So, because we did it right, and it's all on video. Okay, so I think the thing that you have to practice is just being able to do this algebra like fast. You know, because all of this algebra with the quadratic formula,
It took us a long time.
but it's not hard. It's just something you just learn how to do and you just do it. Right? Okay.